Okay, again, when you're looking on this signal here, my question is, where this signal coming from?
The modulator.
Exactly. Output of modulator. Okay. So when you're looking on the signal here, where is your voice?
That's carried on top of there.
Exactly. This is your voice here. Okay. Very low frequency. And they need to see inside here that the frequency carrier. So they carry up to the very high frequency. Okay. So they're able to transmit it. If you're looking at the output of the modulator with the oscilloscope, then you can see this signal. Or that one. I just telling you, very basic calculation. Like on the second one, more easier. You can see AM signal on the scope. And they get a 1 volt per division. If you're looking on that from the bottom to the top here, 1, 2, 3, 4, 5, 6. 6 division mean 1 volt. And in right here, you get only 1 and 2 volt. Okay? VC. Okay? And VM. What VC for? Carrier, right? If you have to be going back to the formula somewhere. Okay, right here they say AM modulation index can be defined by the formula M, VM over VC. VM is the information voltage and VC is the carrier voltage. To measure the modulation index on oscilloscope using the formula M equal V max minus V minimum divide V max plus V minimum. VC equals 6 volt plus 2 volt divide by 2, you get 4 volt. And VM will be different. 6 minus 2 divide 2, you get 2 volt. So that's why you can calculate the index modulation equal VC divide VM divide to V max times 100%. You get the 50%. Okay. Now, if they show you that one, this signal here is your voice. You know, they get a name for this signal. Who know the name?
Envelope.
Envelope. Perfect. Okay. And inside that one, the carry signal here. And that's what they call 100% modulation. However, if you're looking on that one, you can see the difference right here.
Overmodulation.
Yeah, that's what they say, over modulation. The interlesion voltage is too large for the carrier. Okay? First, the envelope is no longer an accurate copy of information. Second, excessive bandwidth that will interfere with adjacent station. Okay? So that cannot be done. They will be over modulation. That means they can make the noise to the next channel. Okay? And that will be 100% modulation. Now, that's what they're talking in general. Frequency domain AM analysis. In this domain, it's easier to measure the bandwidth and the total power of AM signal. Okay? They're showing you at 100 kilohertz and they get the 10 volt. Okay? The 100 kilohertz carrier modulate with 5 kilohertz information. That means your voice in here and in here, and they will be carried by 100 kilohertz. That will be FM modulation. Frequency domain divided. In figure 3.10, okay, right here, on this 3.10 here, and not on 3.11. So 100K sideways in the frequency domain. How do we know this is a sideways? Since there is only one frequency present, 100K. The sideways is the only pure waveform, and it contains only one frequency. What happens when this carrier signal is amplitude modulated in the frequency domain? The rapidly changing amplitude show up a new frequency called a sideband. Sideband are a new frequency generated during the process of modulation. They are created by non-linear distortion introduced by the modulator amplifier. On modulation, create a sideband whether it be AM, FM, or PM. Okay? Suppose that 100K carrier is amplitude modulated by 10 volt 5 kilohertz information signal. The resulting frequency domain picture will look like 3.1. That means it looks like that one. Okay, this is the carrier. And this will be your voice here. What are the sideband? The 5 kilohertz information signal seem to have disappeared in the display. In reality, the information energy 5K has been transformed into sideband energy. That means you get 100K, now you get one will be 95 kHz and another one 105 kHz. Okay? And you can get the frequency upper sideband. You take the carrier, you add in the modulated signal FM, and one will be minor. Okay. V upside band equal VL side band, and they will be equal Vm divided by Q. They given you example. Calculate the bandwidth and modulation index for AM signal shown in the figure 3.11. Bandwidth will be Fmax minus F minimum. Fmax, that means 105, and minimum will be 95. Bandwidth will be 10 kilohertz. And M will be Vm divided Vc. Vc 10 volt. Vm will be 2 volt, 2 times V upper side band, or equal 2 times V lower side band. Okay, and that's what you get a 1. Example. For AM signal show, they want to calculate the information frequency FM wanted in the upper side band, okay, and lower side band. The bandwidth, M, and percent modulation. Okay, so when you understand this is the carrier, 810K, okay, and this is a 5 volt, and this has to be also 5 volt, and the frequency is, let's see, 810K you adding, okay, let's see, how come you get 813? You're adding 3 kilohertz, okay, FM. And if you want that, you take 810 minus 3 kilohertz. So everything you very simple. This amplitude and this amplitude must be the same. So that have to be 5 volt. If you want upper side band, adding 3 kilohertz to 810K. If you want lower, you take 810 kilohertz minus 3 kilohertz. Okay? And the index will be Vm divided Vc. Vm equal to V upper side band divide lower side band. Okay? You can get 2 times 5. Okay? You get a 10 volt. M will be equal to 10 volt divided to 20 volt. And that's why you get 50%, 0.5. Okay? That's a simple example for you guys. Okay? You don't have to do it. But for anyone who want to understand a little more about AM modulation, then try to see. I want to understand a certain AM signal has the following: VC 100 volt, FC 2182K, VM 25 volt, FM 2.5 kilohertz. What bandwidth required by the signal? What is the information in M and the percentage of modulation? And draw the spectrogram of the signal. So bandwidth equal to times FM. That means 5K. M will be equal to Vm divided Vc. Okay, Vm is 25. 12.5, 12.5, 25. Okay, divide 100, you get 25%. To draw the spectrogram, we multiply the sideband frequency and the voltage. Okay, V upper sideband or V lower sideband equal Vm divided by 2. Vm 25 volt divided by 2, you get 12.5 volt. Frequency upper sideband Fc plus Fm. Fc 2182 plus 2.5 here. You get 2184.5 kilohertz. F lower sideband Fc minus Fm. Okay, you get 2179.5 kilohertz. That's so everything in here. Okay, carrier, the value will be 100. And the frequency 2182. This is the upper sideband. Okay, 2184. This is the lower sideband. And the bandwidth will be go this one here. That's what you will be seeing on the spectrum analyzer, not on the oscilloscope. You see, this is the F frequency domain, must be on spectrum analyzer. Power and efficiency. What meter is used to measure the power being produced by the transmitter? In the frequency domain, an AM consists of carrier frequency, a pair of the sideband. The total power is the sum of all the individual power in the signal. You want to calculate the total power. They will be equal power of lower sideband plus power of carrier plus power of upper sideband. Antenna is a transducer. It accepts RF energy from the transmitter and converts it into electromagnetic energy. A resistor is also a transducer. It converts electrical energy into the heat. Energy goes into antenna and doesn't return to the circuit. It appears as pure resistance. Now, see what's going on here. This is a modulator here. Modulator, we already said they get two different signals. One from carrier oscillator, RF carrier. The signal will be very high. And another one is your voice. This is your voice go to the microphone. They need to voltage amplifier, okay, to make it bigger. And they will be go into the modulator. In the modulator, they get an amplifier. Now, the question is it a linear amplifier or non-linear amplifier inside the modulator? Inside here, they get the amplifier. The question is it a nonlinear, or linear. That only thing will be given you the general information. So that's why minimum thing you're able to answer that. What the amplify? First thing I'm talking about linear amplifier. If you already learn some circuitry amplifier, they get the gain. For example, the gain equal RF divided R1. Okay. So that amplifier you cannot change the gain without changing the value of RF or R1. That's what they call a linear. Non-linear, that means they can change the gain automatically. Okay? So, your voice in here, they go into the modulator and they get the carrier go into here. So that they get a amplify that non-linear. They can changing, okay, the gain. And that signal coming out from here, modulator. That means you can see that a signal we already see here. That one. Okay. You can see they can automatically change the signal voltage here. Okay. Automatically. They have to be non-linear amplifier. Then they go to the power amplifier, radio frequency. Then they will be go to the antenna to transmit it over the air. Okay, so now if you're looking into here, they show you what's going on at this point. In here, you can get the V carrier signal. You can get V of the lower sideband and upper sideband. And also antenna equivalent circuitry. That means you get a resistance of the antenna. Okay, let's see. In most common antenna resistance is 50 ohm. Other common, they can be 25, 75, or 300 ohm. Total power will be V squared over RL. RL means the load. Where PT, they can be power lower sideband, power of the carrier, power of upper sideband. Okay. Then power carrier will be equal to VC squared divided RL. Power up sideband, low sideband will be V squared upper sideband divided RL. The AM signal in the figure 3.12. Okay. Being measured across 50 ohm antenna, calculate the following: carrier power, power in lower side, power up a side, total power in the sideband and the total in the signal and the figure 3.12. This is figure 311. I'm looking for 3.12 right here. That means they want you to calculate the power in here. Okay. So they want the carrier power. Okay. They want the upper lower sideband power. They want the total power in the sideband and the total power in the signal. The answer will be the first one at what? For carrier power. Okay. A second one, power in the lower sideband, upper sideband. The total power in the sideband, you adding upper, you adding lower, you get power in the sideband. And you adding everything, you can get the total power. Okay, another shortcut for the total power. PT equal P carrier plus P carrier M squared divided by 2. Or they can be PC times 1 M squared divided by 2. They given you another formula. In order to calculate the total power, instead you have to calculate for each one. Add them up. A certain AM transmitter measure at what? On a watt meter. When it is dead key, unmodulated. If an intelligent signal is then applied, that results in 100% modulation. Calculate the following total power, sideband power. Okay, so 100% modulation, N will be equal to what? Okay, PC equal 8 watt. Okay, that's what is given to you here. Okay, then you get 12 watt. P side band power. PC times M squared divided by 2. You get 4 watt. You can see right here. Okay, that P side. Example, assume the transmitter output of the same figure 3.12 appear a 50 ohm antenna load. Calculate the total power. Okay, so you can try to see, you can get the calculate PC. Okay, you can calculate the index VM divided VC, and you can calculate the PT total. Okay, this formula here. They just given you example. Instead, you have to calculate for each one, then add them up. You can using this formula to calculate the power. Okay, efficiency of AM transmission. Efficiency power of information divide to total power. Okay, so power of information, you get the upper side power, you get the lower side power. set them up. Divide to total power. That means include power carry, power lower side, power upper side. That's what how you want to calculate the efficiency. Okay. Spectrum analyzer measurement. Application for the spectrum analyzer include frequency and bandwidth verification, signal strength measurement, filter frequency response measurement, distortion measurement. They're telling you what spectrum analyzer will be help you to take care of those precautions for using spectrum analyzer. Never connect a spectrum analyzer input to any point in a circuit where a DC voltage is present unless a DC block is installed on analyzer. Always start measure with the analyzer attenuator section set for minimum input sensitivity. This normally means higher dBm or decibel milliwatt attenuator setting. Never apply more than the maximum rate power to the input connector. Most transmitters cannot be connected directly to a spectrum analyzer. The typical maximum safe power level range from 100 milliwatt 20 dBm to 1 watt 30 dBm. It is marked clearly on the front panel of most instruments. Okay, to measure power level greater than the maximum input level, you an approved power attenuator or sampling unit don't leave tap, leave connect to the spectrum analyzer when it is not in use. Spectrum analyzer control group, 5 basic group, center frequency, frequency span, bandwidth, sweep rate, sensitivity. Precaution for using spectrum analyzer. Never connect a spectrum analyzer input to any point in the circuitry where DC is present unless a DC block is installed on the analyzer. Okay, that's what we already talking about. Spectrum analyzer control group, center frequency. The center frequency is the frequency that appears in the middle, as it on the display. Frequency span. The frequency span is the total frequency distance from the left to the right of the display. Bandwidth, the bandwidth control, adjust the frequency solution so the display, for example, to cover frequency span 10 megahertz, 10 division at 1 megahertz per division. A bandwidth of 30 to 300 kilohertz is reasonable to begin with. Sweep rate. The sweep rate control set the frequency of the horizontal sweep oscillator. Sensitivity. The sensitivity control of a spectrum analyzer should always be set at a higher available level when the signal level is unknown. Basically, that's just telling you in general about spectrum analyzer. If you want to working on spectrum analyzer, That's what you have to go more detail. You have to understand what is the frequency span. See what center frequency, okay, and so on. Same thing. When you're working in the company, if you get a chance to working on RF radio frequency, that's what they have to teach you, how to deal with that, how to understand what's going on. The thing is to understand spectrum analyzer cost a lot of money, okay? They don't want damage. Let's say they just want to draw a block diagram illustrating how AM signal is generated. You understand? You draw the block for modulator. Yet you input one carrier, one your voice. Okay? What property of a modulator circuit cause AM to be generate non-linear amplifier? What signal are applied to the input of modulator? RF carrier, oscillator, and information. Okay. What is the envelope of an AM signal? The answer here, the shape envelope of the carrier wave is a replica of the information. Define the modulation index of AM signal. That means they calculate AM. Answer will be VM divide VC. What is the maximum legal? That means maximum will be AM equal 100%. What is the percent of modulation for AM signal with modulation index 0.3? So percent of modulation will be 100 times M. M will be 0.3 to get 30%. For the following AM signal, calculate modulation index and the percentage of modulation. Okay, we might equal 300, we minimum 100. So M equal, okay, that you can follow that. What is the percentage of modulation of a depth key transmitter? Will be 0%. Number 9, what is percent of Number 9, what is name given to the new frequency generated during the process of modulation? Okay, you can get F for lower sideband and upper sideband. Lower single sideband frequency and upper sideband frequency. An AM signal is being produced with the following characteristic. Carrier 560 Hz, VC 1000 volt, FM 3K, VM 300 volt. Calculate the following. They want to calculate F for upper sideband, F for lower sideband. Okay? Upper sideband equal carrier plus FM. Lower sideband carrier minus FM. And they want to calculate the index M will be VC divided VM. Percentage of modulation. You take 3.23 times 100%. That will be, I think 33%. frequency. V upper sideband, okay, equal Vm divided by Joule. Vm at 300 volt, okay, divided by Joule. V lower sideband, the same thing. Bandwidth will be F upper side minus F lower side. You get 6 kilohertz. An AM transmitter operating on a carrier frequency 960 Hz with carrier voltage 20 volt. For each of the following information, voltage and frequency below, calculate the F upper side, lower side, percentage modulation, upper side V, upper side band, lower side band, and the bandwidth. Okay, they already calculated here. Okay, and they want B will be VM, okay, and FM 4K, CVM 5 volt, FM 1.5. Okay, I just given you a more example from the book. Hopefully, this will be helping you. If whoever wants to see, and you will be able to understand. Okay. Now, before we stop this for today, you can see the picture here. This is modulator. Okay. And basically signal coming out here. AM modulation. You need a power amplifier. Then you need to go to the antenna to transmit the signal. That will be transmitter. Okay. Low level. At that point A, B. Oscillator output signal is present. Fairly small. AC voltage, perhaps 200 to 400 millivolt IMF. A buffer amplifier, a low gain, and has a constant input resistance. Then the oscillator see a steady load resistance. Modulator to work must have a two signal, RF, AF. RF means radio frequency, AF means audio frequency. Typical modulus output is around 10 milliwatt, okay, or less. AF voltage amplifier. A microphone only produce a few millivolts of signal. The signal level at the output audio frequency voltage amplified is usually at least 1 volt RMF. Okay, so you can see this in the audio amplifier. Your voice is too very low. They need to make it bigger. Okay, so the last one for next week, we'll be talking about how they transmit and receiver. Okay, and Mr. Sam will be ready for the last quiz.
Yes, sir. I'm ready when you are. Okay, so make sure you download the quiz, the answer sheet from the website, the AC Quiz 08 for the transformer. Okay, so here we go. Share screen. Share. Okay, so we're gonna be looking at this one here. Slideshow. Start from beginning. Okay. Okay, so that's pretty much it. So make sure you upload it to the website for credit, and we'll see everyone in the lab tomorrow. Okay.
Okay, make sure
Have a
you
good
understand.
evening.
Hold on. Make sure you understand on most of the questions coming out from lab vote. Unit 10. That hopefully will be helping you to get in lab vote easier. Okay. Yeah, go ahead, whoever. Got any question?
Let me see. Chat. Yeah, Lo, I think we will have available on Monday. Be on the 15th. I think we can go over this quiz. Okay. Okay, so like Mr. Pham said, Tuesday, Wednesday, Thursday will be lab. Okay. Hey, Lewis, what's up? You have a question, Lewis?
I got a question.
Yeah, go ahead, Nicholas.
What date is the final on?
It's be on the 25th on Thursday.
Okay. Cool.
All right.
Thank you.
You're welcome.
Hey, can I see number 12 from the quiz again, possibly?
Okay, hold on 1 second.
Sam, question.
Yeah, go ahead.
Sorry, my thing wasn't working too, but for going to Tech 2, do I have to go into the system and also like we did last time for summer?
Yeah, log onto your portal and then register your class. Okay.
What would be the? I didn't get the number.
Okay, 1 second. Let me go ahead and share this with Nicholas real quick.
Yes.
Okay, number 12, Nicholas. Okay, you got it, Nicholas?
Yeah, we're good.
Okay. All right, let me see. Minimize this out the way for Tech 2. Okay. Luis Vargas. Okay, so Vargas right here, you're number 17. So your CRN number is 15967.
Okay.
And your permission number is 165925.
Okay, perfect. Thank you.
Okay, you're welcome. Okay.
Bye.
All right. Any other question before we call it a night? Okay, Mr. Pham, we're good.
Okay, so good night, everyone.
Good night.
Good night.
Good night.
Thank you.
Good night.